let's see what we can see here. So there are scanners, right? There are scanner auxiliary modules, and we are particularly interested in SMB. SMB, of course, is somewhere here, right? So let's say we are interested in enumeration of users. Now let's num shares users we already had in Nmap output. So that's what we do. We load Well, what's up? Oh, wrong keyword. Okay, so we use, I'm just confused it with Recon-ng, where use and load are quite synonyms, okay? So here we use modules, and in each module, of course, we have info, right? So here we can read a lot of different information about what module does and what's it for, and who is the team who have created the module. That's HD Moore himself. I also know this guy, Sinner. Of course, you might be already familiar with this guy. He is quite an experienced hacker, and he shares the knowledge on the webinars and in the blogs, and discloses different vulnerabilities once in a while. So, and this is like basic configuration of it, right? So we can, of course, put some remote hosts here, and this is required, right? And basically we can do it either on an authenticated way by providing SMB user and SMB password and SMB domain, of course, or we can just see whether something is open to anyone, yeah, on the network. So let's see how it works. Of course, there is a shorter version of this information command. It's just showing the options section, right? And we can set here our hosts to our IP address, so the target machine, check whether everything is okay, and then just run. Okay, so login failed, but that's not a problem. We have successfully identified the service pack. You see, I have lied to you in the very beginning when I said that this is SP2, this is SP3. And IPC is remotely accessible. Shared docs is shared to the local network by the default user, and there are some administrative shares here, C and admin. These both are virtually every time you enable networking and the network file and printer sharing on Windows XP machine, these two become available like to someone. Yeah, you have to still have an authorized credentials pair to access it, but it's there, it's publicized, and it can be read in such a manner. Okay, so now we go back to the root context, and now we will spend some time to show number of exploits. As you see, you can browse to context, you can then go back, you can load another context. Unfortunately, you cannot leave a context running, but once you have configured the module, right, you can run it on the background with this configuration, and you can save configuration for a later use. But yeah, you will have to come back to this context, and then this configuration will become available. So let's say we are going back to this SMB num shares and we show options, most probably it will still be here, but between the runs of Metasploit framework console, this configuration will disappear and will just fall back to defaults, right? And to leave this like it's already configured here, we have to do save, right? And then it will be saved between runs. Okay, so now we see a lot of different exploitation modules. As you see, most of them have disclosure dates. I think virtually all of them have to. Okay, and some entropy, right? Some variations we can see in reliance in the rank of the module allows us to choose what exactly we will use from here in order to exploit that vulnerability or another, right? So let's see what we have here. Again, we need the Windows SMB section, I guess, or it's Net API. Yeah. Oh no, it's Windows. It has a short name. So let's just see. Yeah. So we can find it by this notion, and we can see that it's quite old, and the reliance is great. You will see that that's the fact right now. So let's just copy that and use this exploit, get some info on it. Yeah, as you can see, it's super reliable. It's working in most distributions in both SP2 and SP3, right? And in the Windows Server version available at nearly the same time as an exploitable XP. So as you can see, again, so we have JDoc here, we have HDM, and everything we have to put here is the remote host, and we have to have this port available on the host, which is available all the time. We enable network printer and file sharing. So let's set our host to okay. Check the options. Yeah, one more thing. Every time you configure a context, you configure a module, you can put more configuration options here than available in show options. Yeah, so you can put some authorization credentials here. You can put you can select the workspace from within the framework. You can use proxies. This is all configurable, and most importantly, no, that's not here. That's in payload configuration. So here, let's just see that options are okay. Yeah, so we can run either by command run or by command exploit, and it has some command options as well. So the background exploitation, what I told you about, is this. Yeah, so -j creates the job for that, and it's waiting for incoming connections and will exploit everything that comes, or it will interactively exploit the vulnerability in the remote host and give us a shell basically. But for that, of course, we will have to define the payload, right? So there is this payload vulnerability we have to enable in order to run something on the remote host, on the target host, once the exploitation has been successful, right? So let's first show payloads to choose from. There is quite many of them, but let me introduce you to Windows Meterpreter, which is the most useful one by all accounts, right? So we will use it in. It has many modes. It can bind to some TCP port. It can bind to. It can reversely connect the back, right, via HTTP or HTTPS, for example, right? It will basically encapsulate its communications to HTTPS, okay, just for it to look as a legitimate HTTPS traffic to the outside world. Yeah, for a passive observer, it will look like someone on your target machine is visiting an external host by HTTPS. Of course, for that to be least suspicious, you will have to make it like back resolvable, so it should be some real host, right? Not an IP address, because HTTPS connections to IP addresses is quite it attracts unwanted attention. You don't have to be super sneaky in your operations, but once you do something like this, you have to remember that overall HTTPS is relying on two things: a certificate and the correspondence between the domain name and the certificate and the IP address that it resolves to. Okay, so the certificate has to be posted, has to be published on somewhere that is available by a DNS name. Okay, so if it's not, it most probably is malicious. At least it's suspicious. Okay, no one is putting HTTPS services on raw IP addresses, and yeah, except for us, once we do not prepare well enough for our exploitation operations, right? So here, as long as we are in the local network, reverse TCP connection will suffice. Okay, so we will set payload to this Windows Meterpreter reverse TCP, and we once again will inspect the options. And here we will have to put our local address. Why? Because this is like a configuration of something that will be binary, like imagine it as not compiled but packed into something that will pass to our target machine and then be run there in a standalone mode. So it will definitely need some information about where to connect back to. Okay, so let's set it to what we already know. Right. Okay, so I think we are good to go. So let's see how it works. Well, of course, Ruby wants to listen to some incoming connections, and now when we have enabled that, let's run exploit again. So the stager is there, and then our favorite MSF message, Meterpreter session 1 opened, appears on the screen. So this is quite cool. We have Meterpreter. Okay, so this is the basic exploitation we can accomplish against a networked host somewhere out there. So let's see what happens on the target machine. We have something. What do we have here? We basically do not see it because it's like it's a fork. It's a process that has forked from some system process on the local machine, right? So for that to be visible, we will have to print all the connections, and from there we still don't see that. Okay, so as you see, oh, here it is. Okay, so DLL for sockets Microsoft Windows has established the connection to the port 404s on our machine, which is kind of old school and it's not cool at all, but still, just for the sake of an example, I think it works fine. So let's take a pause and then go to post-exploitation exercises.